am going to get started. I have minimal time and about a 90-minute slide deck we're compressing. So we're going to fly right through this. So you're here for digital transformation is security transformation. My name's Allyn Crowe. You can find me with my email address there or come see me down in our booth. We're sharing with F5. I can talk a little bit about this, but I could talk all day. So if you're interested in Nexum, we're a value-added reseller. We offer everything from product to services to training to support and MSSP. So today I'm going to blast through this agenda. There's a lot of content to put in. I'm very interested in your questions. I would love to talk with you, but I don't have a lot of time to do it now. So at the end, if I have time for questions, I'll be happy to take them. Otherwise, come see me and we can chat in more detail. So as we start talking about digital transformation, we really want to talk about what is digital transformation. So trying to figure out what this means can be dependent on who you're talking to, what market you're talking to, and what part of the business you're talking to. Wikipedia defines digital transformation as the use of new, fast, and frequently changing digital technology to solve problems, often utilizing cloud computing, reducing reliance on user-owned hardware, but increasing reliance on subscription-based cloud services. Does that clear it up for everybody? Everyone good with that? You can respond, it's okay. You've had some time for coffee. The fun thing about this is with Wikipedia, as with everything on Wikipedia, you can change the definition if you want to. And so there's a lot of conversation about what Wikipedia says about digital transformation. The problem being it's out of date every time someone writes about it because someone then goes and changes it to fit what they think digital transformation is. So I used to work for a digital signage company. And we worked with everything from Fortune 50 clients all the way down to places with 1 or 2 shops. And with those, they talk digital transformation all the time. That could be something as big as working with a Fortune 50 company to create a signage system that allows them to update their menu board across the globe, enforce brand standards, bring in video and animation to really drive a customer interaction. It could also mean talking with someone who used to write their menu on a chalkboard and they took a picture of that chalkboard and they want to put that on a TV. And both of those groups would talk about that as being a digital transformation. So as we start digging into this, we really have to look at what does that mean to the clients that we're interacting with. And so for me, I like to think of digital transformation as transforming a business's engagement with their clients utilizing technology. So overall, the process of digital transformation can be reliant on technology and thus reliant on us as IT, but it shouldn't be driven by us. This really is a business decision on how they drive it. So there's no specific product that is going to do digital transformation for everybody all the time. And in fact, as we talk digital transformation, there is no product that does digital transformation. There's products that help with it, but overall this is an architecture and a solution, not a product. And so what does this mean to us as IT and for those of us in security as IT security professionals? See, if we think back a few years before this started to be the buzzword, the driving force behind us, we had these wonderful things that were starting to be stable. We had ITIL that were giving us standards for how we worked. We had enforced change control. We had set solid release cycles that people didn't get to violate. And then this comes up and we start to see a shift where IT starts to lose control of technology within the business. See, IT had controlled the technology spend budget, right? We had that. If it was technology, it came through IT. And if something new came up where a business unit said, hey, I really want to try this new thing, the common response I know that we certainly gave was, well, it's not in the budget this year. We'll have to look at it next year. Or, well, our release cycle's locked for this time, but we can look at it for next time. And so digital transformation came in and the business unit started saying, hey, you're not responding fast enough. We need to do this and we need to do this now to stay relevant. And so our business owners are starting to come to us with technology suggestions, right? I want the app to do this. I need to be able to release things faster than every month. I need to be able to tie our services in with our business partners, and it needs to happen seamlessly behind the scenes. I can't have my app pop up and now take me to this other person and lose that brand capture that I already had with my client. And if IT can't help them deliver these things, they'll go off and do it on their own, right? Anybody heard of shadow IT? Nobody? One person in the back? All right. We're going to do buzzword bingo later. I mean, no? Wow, dead. So the business is no longer happy with us saying, hey, we did the best we could. We'll try again next month, right? They now want to see validated results. How did you do this? How did they respond? What was the interaction change? And we're seeing more and more technologists move out of IT into those business units. So business units are starting to own their own technology pieces. So the CRM, right, is not managed by IT much anymore. It's managed by marketing, or it's managed by sales operations. It's not in IT. IT needs to start providing that framework that allows the little bit is how do we mitigate this risk? How do we handle this risk? And so later on today, you're going to have a keynote on zero trust. I was kind of hoping it was in front of mine so that I could skip through some of my slides as a review, but you know, this is what we've got. Zero trust is the first piece of the architecture I see us in IT using to help build this framework for our businesses. Zero trust is very buzzwordy right now, right? Everybody's talking about zero trust. Zero trust this, zero trust that. My product will enable you to do zero trust, which is an absolute lie. If anybody says my product does zero trust for you, they don't understand what zero trust is, which luckily NIST recently released their paper on zero trust architecture. And so you can Google this, so it's NIST SP 800-27. You can get a PDF, it's still in comment phase. So they're looking for feedback, they're looking for that information, but you can get it and see what they say. And the good thing for me is that they're very explicit that zero trust is not a product. It's an architecture. And it's an architecture for eliminating uncertainty and enforcing accurate access decisions. And so we're going to dig into this a little bit more. As we do that, again, I'm going to hit on this, and I'm an engineer, right? So I don't get paid to sell product. I get paid to make stuff work, and I get paid to build stuff that works. And a lot of manufacturers are saying they're trying to define zero trust into what they sell. And that's just not the case. So to really get there, in fact, you're probably going to have to wholesale replace a whole chunk of your architecture. Unless you've been lucky to be building towards it over the last 10 years or so, there's a lot of stuff that's going to go into zero trust and how zero trust works. But ultimately, the goal here is that the sum of what you have, the whole of your architecture, is better than all of the pieces put together. You get that synergistic effect that used to be the buzzword. And today, zero trust is really where you're going to realize that. But part of this is you're going to have to be flexible. You're going to have to take a step back and be able to solve this problem of how do I effectively authenticate people, as well as applications, data consumers, APIs. How do I authenticate them in a way that's secure, that I understand that it's more than just a particular person? In fact, we have to do that in an environment that's becoming inherently more and more hostile, including your internal network. If you have one of those anymore, I'm a remote employee, so I would hope that 90% of the time I'm working out of my house. Let's give it a good 75, right? But of that point in time, I'm not on VPN. So I'm working with clients, I'm working in my internal systems, and to be able to authenticate me so that I can function properly, that's the internal network these days. And so a lot of the pieces that go into this is things like contextualization. So no longer is a username and password enough. So this needs to take into account location. Am I here in Louisville? Am I up at my home office in Ohio? Am I in my headquarters in Chicago? Or is my authentication coming out of Shenzhen, China? Right? These are all pieces that feed in. And then you start taking in time of access. So what time of day is it? Is it 4 a.m. where I'm at? Unfortunately, that's not a good definition for me because I work whenever I work. But did I just authenticate in Ohio and now 2 minutes later I'm trying to authenticate out of somewhere overseas. So those kind of things, as you start to put together that contextualization surrounding the authentication, that's becoming important. We're talking about RBAC, role-based access control. We'll dig into that a little bit more. Least privilege or strict access control. And it's operational as well as preventative. It's no longer good enough to just have preventative measures. You have to have the operational pieces behind it to monitor, log, and then respond to authentication attempts and potential anomalies. And the biggest thing, zero trust is never done. You've never finished implementing zero trust. You need to constantly be checking out what's going on. As your threat environment shifts, you need to be able to tune your systems and tune your controls that surround those to match what your threat environment is today. So the first piece of the zero trust that we're going to talk about is going to be strong authentication. And that doesn't just mean you're also using a multi-factor piece. So multi-factor is helpful, but you also need to look at things like mutual authentication, where rather than just a one-sided authentication, the other side is also going to authenticate back and check both things. It's contextual, so that's, again, it's beyond just their credentials. It's location, it's time of day, it's unusual times, it's checking for time travel, multiple logins. All of those pieces feed into that context surrounding the authentication request. And it really needs to support non-human transactions. So what do I mean? Things like cryptographic exchanges, challenge response within system-to-system authentication, and API keys and/or API authentication. Right? So all of those pieces need to come together so that we can have that strong authentication. Once you're authenticated, you've got to move into least privilege. So least privilege model is going to give you the least amount of things that you can do on a regular basis, right? So it's a relatively simple concept. And the way that I think about it is user account versus administrator access, right? So day to day, I can use my standard user account. If I need to do email, if I need to write documents, if I need to work on slide decks that put everybody to sleep, that can all be done via my user account. But then there's occasions where, hey, I really need to get in to do this. So I need to set a route on my laptop because my client IPs overlap my IPs. Or they didn't set up DNS entries for the routers I need to get to. Right? So at that point, I need to have some level of administrative access. And that can be as simple as on a Linux-based machine, being able to sudo. On a Windows machine, run as administrator. Right? Or in some cases, log into a dedicated administrator account that's only accessible within a secondary login. And so this way, on a day-to-day basis, I'm not actually exposing those administrative accounts, those administrative privileges unnecessarily. And so the fun that we have with this, especially on the IT side, is how does an organization balance least privilege with the ability to maintain and run that system on an ongoing basis. So if I, as an administrator, have to log in 15 different times with a 34-character password that has to have at least 5 uppercase, lowercase, non-matching characters, 3 special characters, and 4 numbers that don't match anything else, and I haven't used it in the past 6.5 years, it's a little bit of a challenge, right? So there's a balance that has to be done here. And so as we start to look at least privilege, it has to be implemented within the tools, within the applications. This has to be built into it, which all ties us into role-based access control. So role-based access, has anybody heard of role-based access control? Hey, there we go, you're waking up, right? RBAC. So RBAC is going to get you into fine-grained access control. Your role tells you what you can do in the system. Your group tells you where you can do it, right? So your role may be guest, maybe user, maybe editor, maybe admin. The group then gives it for specific functions, right? All of this ties together. The groups then tie this together, and you assign access users to those groups. And see, if you don't do this, you start to lose control. How many of you used to assign privileges to specific user accounts? Oh, come on, raise your hand. We all did at one point, right? Before grouping started to come in. Now, how much fun was it when someone said, hey, we've got 50 new users, right? So being able to group this out allows us to maintain control. The fun then becomes when someone says, hey, we just contracted with this third-party agency and they're going to manage all of this for us. We need you to be able to let them in and give them access. How many of you want to add that company and their entire directory to your systems? Anyone? No. Right? So this is where we start to talk about federated identity. So we allow federated identity to build that trust relationship with other entities, whether that's a third party, whether that's a contractor, whether that's internal divisions that we have separation of access from, right? Because what fun is it when you give someone administrative access and then you find out 6 months later, hey, that guy hasn't been here forever. He was fired because he was doing bad things. And his admin account has still been valid the entire time. How much fun is that? Who wants to go back and do that data check to make sure nothing's been done, right? And so what we have to do is establish trusts and relationships with other groups and make them, through that trusted delegation, actually handle the pieces of authentication while we maintain control over what they do. And see, this is all necessary for agility, right? As we start talking through what these things do for us, is it gives us the business agility necessary so that we don't have to manage and maintain and become a roadblock. And so as we start looking at this, identity as a concept continues to expand on what we're actually talking about. It's no longer just username and password and maybe a group that they're a part of in their original. But we start to talk about things like background dossiers being part of identity. Or in healthcare systems, some certain amount of healthcare information being part of that identity that's now shared and federated between the two organizations. And it's a pretty cool, relatively extensible framework. As you start looking at these things, more and more data can be used to exchange as part of that federated identity between the two. But you have to then realize that that identity now needs to be protected itself. It's no longer just a username and, oh, we need to hash the password so that they don't know the password. We've got a whole lot more data that now we're having to protect. And so while we have the ability to define this, we also have to have the ability to manage it and to work with third parties without breaking it, right? And so as we start looking at this, a good way that we can do that is through the concept of microsegmentation. So we can have our system that interacts with third-party APIs, that has databases, has large complex applications built on top of multiple modules, and all of those pieces, and the only thing we expose to our user is one web port. Right? Gone are the days where we had to open up certain database ports so that the database could interact with the JavaScript, so that they could build the page, so that they could pull the data, so that they could see the price. Right? All of that's done on the back end. And with microsegmentation, all of those touch points become our edge, become our security edge, where now we're actually defining our security interactions at each of those touch points. Right? So these foreign APIs that we're building into and that we're working with as our third-party interactions are actually secured in and of themselves, unique to that interaction. This allows us to do things like determine what access, apply least privilege to the API integrations with our back-end systems. Whether that's user, application, infrastructure management, all of those pieces tie together and can be secured individually and uniquely. And this allows us to prevent east-west or lateral movement when there's an indicator of compromise. Because should something get compromised, or as it gets compromised, ultimately everything will be compromised if it's left alone, right? We're gonna start to see flags hit because we're gonna hit more and more security policies. So our web front end is exploited, someone manages to hit it, right? And as they try to reach back to the database to get the actual information, we're going to see flags because they're doing it in a manner that is not consistent with how the application operates. And so ideally, that IRA team is going to see that and they're going to respond and they're going to be able to do it faster because there's more flags that get thrown the deeper they try to go. And this is going to limit something, hopefully, to just being an exploit before it actually becomes a true data breach. And so all of this ties in now to our security operations team, right? So our SecOps team is going to be responsible for, detection, response, because no preventative control is perfect. Given enough time, everything will get hacked. Given enough exposure, everything will get cracked, right? And mistakes happen. Anybody heard of phishing? Verizon's report this year said last year 32% of all of the data breaches were started with a phishing of some form. It's a full third. And I'd say probably another half of what's left was really phishing, but people just didn't accept it. See, apps and devices get misconfigured. Entropy happens. People set something up once and just expect it to keep working the entire time. Tools crash, logs get dropped. And see, what we need to have is the ability to identify situations where we have an application, an environment, or a trust relationship that doesn't actually match our organization's risk posture, right? What's acceptable risk for the organization, and how do we document that? And we need to have an exception process. When something doesn't fit that process, doesn't fit our standard stance on how we secure things, we need to have an exception process to allow for a non-adversarial relationship with our business folks to allow that to happen. How many of you ever had to set up an IPsec tunnel between you and a third-party provider? One, maybe 1.5. All right. That's always fun. Setting up IPsec tunnels between two businesses, it's more than just a, hey, here's your IP, here's your password. There's IP overlap, you've got to talk about policy, you've got to talk about who can access what, where can you access it, how can you access it, right? And then you always have to wait for the change control to go through. And so I know I certainly in my former life when I was setting up tunnels, that could be a 1 to 2 month process if I'm talking about a Fortune 50 company to get an IPsec tunnel up so that I can actually provide them with the services that they're paying me to provide them. And so having that exception handling process, how do we do this faster? How do we enable our business to be able to accelerate their innovation becomes a key point. And so now we can also start to proactively work together once it's in place. We put an exception in place, we need to then come back and fix that exception, right? So we'll give you an exception for a month, but at the end of that month, we're going to reevaluate this and figure out why it's still an exception. And part of that then becomes putting compensating controls around that exception. So yes, you have an exception. We're going to give you a month to figure out why you can't go through our standardized process, but we're going to log the crap out of every exchange that you do with us. Because we need to make sure that we still understand you're not trying to get outside of your lane. And this really needs to be documented in some fashion. And it needs to be documented over time. You should have, and we'll talk about it in a sec, a governance system that allows you to manage these interactions over time and be able to report back on them. We had 15 exceptions last month. They came up on their due date this month. This is the logging, this is what we saw, and this is how we resolved half of them. The other half aren't resolved. We're going to resolve them next month with this process. Make sense? Anyone? Did I put you all to sleep? Working on it? Let's talk about one of the biggest tools in our toolbox as we do this, and that's the SIM, right? So Security Information Event Management System. And this started off as a simple thing of, hey, we need to aggregate all of these logs. We need to put all these logs in one place so that we make sure that we have them stored off box, so that if that box gets compromised, we still have all the logs. And then they started moving into correlating events, right? So, hey, our firewall saw this, our endpoint system saw this. Maybe those mean the same thing, right? And then starting to add in things like threat feeds, right? So being able to see those outside feeds to say, hey, we know this is becoming a bigger and bigger problem for people. Or we know seeing this over here in this group of people, they saw this, what led to an indicator of compromise. That might be the same over here that matches yours. And see, now they're able to correlate multiple input data sets. All of your devices can feed into your SIM if you can afford to pay the SIM per item fee, right? We can get threat intelligence, all kinds of fun and cool things that those SIMs are starting to do. And they're going to try, the best placed SIM is going to be tuned where it's feeding all of the noise in, it's throwing the noise out, and it's alerting on the things that become important. And so this allows you to keep your false positives low, right? So false positives, making sure the stuff that looks bad actually isn't. We want to keep that low. And we want to keep our false negatives even lower. Those are the things that actually are bad, but don't look bad because it's an isolated case, right? No longer we're talking day 1, we're talking day 0, we're talking minute 0, right? We don't want to be the first person who sees an exploit because chances are it means our system isn't going to catch it. But we want to keep those low. They can also be camouflaged, right? So the wonderful thing about machine learning is the bad guys can use it too, and they can change and they can understand those systems. And so all of this leads us to be able to better deploy our resources. So rather than chasing logs or chasing things, how many of you any of you used to read logs? Let's look at yesterday's logs and see what popped. Anybody? Nobody ever looked at firewall counters? Nobody? Wow. Maybe that's a good thing because now you're looking at your SIM and you're seeing the alerts from the SIM. Anybody? Nobody either. Wow. Okay. That's fine. The other fun thing we're starting to see in the SIM world is we're starting to see vendors build SIMs into their own ecosystems. Right? So we had one client that deployed an ecosystem SIM surrounding their firewall environments. And when they did that, the logs that they were actually sending to their SIM dropped by 40%. And it allowed them to see only the important alerts from the firewalls in the SIM itself, which allowed the SIM to better focus on just aggregating and correlating events. And so there's opportunities here to take advantage of what becomes a multi-stage process, right? Multi-stage SIM starts to allow you to kind of funnel down the most important stuff. And then the endpoint SIM is only going to pop the things that become really important. The fun with that is making sure you're not over-tuning it to where you're tuning out those pops that we haven't seen before. And probably the last thing that's not on the slide, but probably should be, is SIM is not a magic bullet. SIMs require a lot of ongoing care and feeding. They require someone to actually look at them. We've gone into clients before and said, so how's your SIM operating? They said, oh, great. When was the last time you looked at it? Well, when were you here last? Right? If you're not looking at your SIM, if you're not seeing the alerts that are coming out of it, it really becomes a great log aggregator that is there for when you get breached and someone has to do investigation. And really, that's not how you want to use it. You want to pull it into that preventative side of things. All right, one last piece on Zero Trust, and that's governance. So all of these pieces are going to come together, right? And now we have to ensure that as we start doing rapid deployment of new applications, whether they're our own or third-party services, that they fit within our risk tolerances. Right, so this includes specific controls surrounding authentication and segmentation, defining our acceptable risk, defining our risk tolerances within a system that allows us to then correlate and aggregate all of our build-outs. See, it's no longer good enough to have that. Before you go live, you have to follow this procedure, and you have to pass this security scan. Anybody dealt with that? No go live till you pass a security scan? One in the back, two in the back, right? So that's no longer good enough because people are trying to constantly deploy more and more. And as we talk about systems, and we'll get to it here in a second, the cloud is no longer utilizing a monolithic system, right? If we need more access, we're not adding CPU and memory to a machine. If we need more bandwidth, we're not ordering a bigger pipe from our ISP. And so we need to have the system, a governance system that enables us to track and accelerate our business, but stay within our risk tolerances. See, we have to define and monitor our key controls. And these are high-level checks. These high-level checks, the key controls, aren't going to be the ones that say, hey, by the way, on the 93rd line of this particular module, you have a variable that's undefined that will be allowed to be exploited through a cross-site scripting error. Right? That's not a key control. A key control is going to say, hey, there's a problem somewhere in here. And that's going to be that high level point to enable you to say, hey, we need to dig into this. All right, anything more than that, we start to lose the fight with agility. And so this then ties back into how do we handle that acceleration, that agility, when there's a problem. So having that exception and the compensating controls as piece and part of this. The fun of this is it's just like security awareness, only worse. And what we're looking for here is not just compliance. Because compliance means I will check a box fast enough to get you out of my way so that I can do what I need to do. We're looking for buy-in. We're looking for buy-in from business. We're looking for buy-in from developers, from the engineering teams. Because buy-in says, I understand why this is important, and I want to build this into my entire process so that I don't have to do things at the end. How many of you have written code? How many of you have documented your code after you were done writing it? How many of you documented your code as you went? Yeah, a whole lot less there, right? How many of you got to the end of writing your module and you go, I don't remember what I was doing here, right? So making sure that it's done as you're rolling through makes it easier for everybody in the long run. So that's zero trust in a nutshell. High-level points here, right? Architecture, not a product. We're confident that the identity is who they say there are. But while we're confident, we're keeping them to only the things they need to do. We're isolating systems and applications from each other. And we're combining that with operational visibility and having a governance process in place so we can keep the whole thing running. Let's talk about the cloud. The cloud's a fun one. Because if you'll pardon the pun, it's a little bit amorphous. See, and what it comes down to here is we start talking about cloud and true cloud adoption, we're talking about everything as a service. When cloud came out, it was rainbows, puppies, kittens, and unicorns. It was going to save the day. Anybody hear that? Anybody? I can get rid of my data center because I'm moving to the cloud. We're going to save money because we're moving to the cloud. Nobody heard any of those things? Anybody have cloud conversations? Okay. Right? So everything is a service. Cloud has become the most overused term in IT. And what we're talking about here are multi-tenant applications and third-party hosted IT infrastructure. That's the biggest piece when we start talking about cloud of what we really mean. So let's talk about IaaS, infrastructure as a service, right? At the end of the day, this is their core infrastructure. It's your IT environment. They're handling everything below the VM. However, I am putting this in caps because I am yelling it. I just won't do it through a microphone to save you. You own your security. The security that they put in place is to protect their infrastructure from you as the client. That's the goal in an IaaS with a cloud vendor. So cloud can be a combination of VMs, containers, or workloads as they'll call them. And then we also add in relational data services, IoT, serverless computing, storage. We have clients that say, we're moving to the cloud. We're moving all of our stuff up to AWS. And our answer is, are you moving to the cloud or are you moving to EC2? Because EC2 is just server computing up in someone else's data center. Right? They're converting their current physical boxes to a VM that runs up in Amazon and they've moved to the cloud. But at the end of the day, if that's as far as they're going, they're not taking advantage of what the cloud can actually offer to them. And one of those things that we get to deal with is there's still an edge in the cloud. And in fact, I would say there's a lot more edges in a cloud environment than there are in a data center environment. So we have to put things in. A lot of the breaches and a lot of the things that we see are people that don't think they need to protect their edge when it's moved up into the cloud. So they P2V to server, physical to virtual to server. They moved it up into Amazon and said, all right, we're good to go. We're in the cloud. And they forgot to deploy a security control, or they forgot to deploy a virtual edition firewall, or a WAF. And now all of a sudden, all those things that used to be protected because the security team handled them are wide and open to the internet. We have to remember the least privilege. So if you put your database server directly on the internet, you are not using least privilege. That usually gets at least a giggle. I mean, come on. Nothing? So AWS has an awesome RBAC system, but you have to actually use it for it to work. We have to make sure our operational governance is still at play. We need to use MFA for console access. If you're not using multi-factor to secure that interaction with a console in the cloud, you're going to have problems. Data encryption, so built-in features. Look at the cloud system you're about to utilize. Use the security features built into it. Azure beat the rest of the major cloud providers to providing a cloud-native SIEM. We really didn't think it would be Microsoft that got there first. We thought AWS was going to release their cloud-native SIEM first. Microsoft beat them. I'm very happy that Azure actually has it because it is a Microsoft product. No giggles. Wow. All right. As we get into this too, we need to monitor, log, and analyze. So you're going to have a whole lot of telemetry coming in from the different pieces of the cloud, and it looks different. This is new telemetry. We don't understand what these things are. But as we start diving into them, we realize in a lot of cases it's the same as the logs we're familiar with. It's very similar to a firewall log. Right? So the telemetry we're getting out of the cloud routers as we start looking at them are similar to firewall systems or VPNs. So we can understand that telemetry within that light and then realize how we're going to utilize it. Because at the end of the day, there's more security operations. So let's talk about AppSec. The fun that we have as we move up to the cloud is if we're not able to find what we're trying to do as a service from someone else, chances are there's custom code that's going to be involved here or custom functionality that we need. And so we need to remember here, the cloud vendors are not going to protect you. You have to protect yourself. I will say that again and again and again because we see it with too many clients that think because they're with a cloud provider, they don't have to deal with security. So things like misconfiguration happens. Anybody heard of S3 bucket exposures? Someone puts their files up in S3 and they are good to go because their data is in the cloud and they forgot to secure it. So as we talk about Capital One's breach from not too long ago, that was a cloud security failure. What they did, they had a malicious admin, so it was user-based, and they were able to trick one back-end service into believing another back-end service and requesting data that it wasn't able to happen. Which on one hand, we'll talk about API security, but if they missed that, they were missing some of the operational components that need to go into that API security side of things. A lot of times we have security group failures because we assign those privileges just to get something working because we need it right now, and then we leave it open. I won't tell you how many firewalls I've got into that have all kinds of security policy, and the last one is allow any. Right? Great firewall, you're allowing everything through that you didn't think of. Right? So it happens, and it happens a lot as we start to move into the cloud because we're starting to use services that we don't necessarily understand. We turn on a feature because someone says that it'll work. We've read it in a white paper on the internet after we Googled how to get this thing working. Right? So we turn this service on because it fixes it. That got it working for me, and we don't understand what we actually turned on and how we allowed unexposed systems to now be exposed through a back-end way. I really wonder how many breach investigations start with, but I thought, right? So it's not that the person wasn't well intended. They were trying to get things working. They may have even had all the security controls in place, but due to unexpected consequences of turning on, of twisting that knob or flipping that switch, now they've done something that they didn't know that they were dealing with. And so we have all of those pieces going on, and we haven't even written our code. We've just set up an environment where we can put our code out there. So now as we start talking about software vulnerabilities, it's those things that we create as well as the things that we import. How many of you use libraries in code that you didn't write? No one. No one out there writes code. All right. So there's these things called libraries. Someone else writes them. And I decide I need to use the function that they're providing, so I use that library. If I don't understand the source of that library, if I don't trust the source of that library, they can write whatever code they want, and it's in a little black box. And as long as it spits out the export that I expect, I think it's good. The fact that on the back end, it's a hacked library that's been man-in-the-middle attacked before I checked it out at Git, and it's also sending all of my data over to their server, well, you know, unless I'm checking for that, I don't know that's what's going on, right? So we have to make sure we are including security in our software development lifecycle. So things like third-party libraries, container layers, databases. We're actually using tools that build right into our IDE. We're testing at check-in to make sure we're scanning at check-in to check and see what's going on, right? We're talking about DevSecOps. It's no longer just DevOps. It's no longer just SecOps. We've got to put all of that together at the same thing. And then we're also doing runtime operational checks. So we have a WAF that front ends our application that checks for those kind of unexpected things hitting. And on the back end, we need to have API gateways, which is really just a WAF for your APIs. Right? And then monitoring. So this needs to feed into our SIM to make sure we understand what's going on. So let's briefly talk about APIs. So APIs are their entire goal is to integrate and communicate between different systems. But we have to protect them because if we don't, they will integrate and communicate between disparate systems. That's their job, right? So we have to, they're all about the data. They're not presenting the data, they are just feeding the data, right? So we've abstracted the UI from the data, and that API is what allows those two to connect. There's two major types, Simple Object Access Protocol, or a SOAP API. This is a standardized, formalized API, which is really good because it's standardized and formalized. The problem is when you use it, you have to use it all. You have to accept the entire standard. So that drives us into a representative state transfer, or a RESTful interface. Anybody heard of a REST interface? Anybody used a RESTful interface? Anybody? Okay, a couple of you. Right? This is much more popular because it's convention-based. And what that allows it to do is quickly adapt and be structured so that it can adapt to whatever needs to be handled through the API. And we need to start talking about identity delegation or access delegation, which is, we can talk about OAuth, where I'm not handling the actual authentication, I pass that out to someone else handles the authentication, and then passes back and says, yeah, they're good. I still control what they can do within the system, but I don't have to handle the username, password, credentials, multi-factor authentication with a CAPTCHA that I can't ever quite click all the little traffic lights, right? Traffic lights, traffic signs, and you click, where are the mountains? The mountain ones are fun because it's like, well, what's a mountain to you? Right, see, OAuth declares my consent. OAuth allows for consent. So I'm allowed to send someone to the bank for me, but the bank still decides what they can do. And again, to talk back to that Capital One breach, it was a failure within API security. So it was a server-side request forgery. It was all server-side back-end API stuff, and the admin was able to convince a different database system to give them the information that they wanted, even though they weren't actually allowed to have it. So your AppSec rule still plays. And as we talk about things like non-IP service security, right? So how can we do network security if there's no network? As we start talking cloud services are usually done via URI. So now we don't have a network that we can put a firewall on. How do we handle that? So that's where the cloud native tools really come into play, because they're designed to be implemented in those kind of interactions. IoT, anybody heard of IoT out there? A few of you? If I wait, more hands will go up. If nothing else, just to get me to keep moving, right? So IoT is fun because it's, on one hand, you have the operational side of things, right? The SCADA folks who if they put a firewall between two robots and that introduces 5 milliseconds of lag, that's going to cause a bolt to go through the middle of a windshield as opposed to into the side of the A-beam. Right? So on the manufacturing side, security within that manufacturing network becomes a problem because it's meant to be so real time. And it's not real time as us network folks think, which is, plus or minus 10 milliseconds of lag, we're fine. Right? The second side of things, and the reason why IoT has become such a buzz phrase in security is because everybody wants to have their camera plugged into their network so they can see what their dogs are doing at home when they're not there. And the guy who's selling the dog camera, that he bought the chip off of someone out of Shenzhen, China, who may or may not have actually developed that chip, and they may or may not have stuck a tracking module within that chip that nobody knows about. Hello, Supermicro. But they allow these things to happen. So IoT devices are made for rapid deployment. The problem with that becomes they don't have the infrastructure underlying that hardware or software to actually be able to support security controls. I cannot tell you how many cameras I've talked with people and they go, well, we allow a username and password. Well, okay. Does that authenticate anywhere? Can you do off-box authentication? Well, we allow a username and password, right? They don't have the ability to add those controls. Containers. So anybody heard of containerization? Right? The short version is you have a base image, you layer containers on top of it to build out your system. Just like with APIs, just like with code libraries, you need to trust where those different layers in your container environment come from. You need to secure those. You also need to secure your container environment. So as you go through this, there's a supply chain that you have to make sure you're securing. Don't forget your SecOps, don't forget your AppSec, don't forget your least privilege and RBAC. All right, we're coming in the last few minutes. I got 13 slides left, so it's not happening. But what we've got here is as we talk about things like DevOps, continuous integration, continuous deployment, this is all about agility. Anybody heard of agile development? All right, who's heard of waterfall development? All right, we're getting there. Right, so this is the heart of IT. This is, we're talking about pets versus cattle. Anybody heard of pets versus cattle analogy of the cloud? How many of you want to take a pet out and put a pet down? Right? How many do you think when you're raising cattle, they care very much about putting a particular animal down? Right? So, pets. Those are the things that we care, we feed for, we maintain. Those are the servers that the only thing we're looking for is how much uptime can I have? Who here has turned off some kind of device that had over a year of uptime and you almost cried a little? I had one router. I had a routing system that had 6 years, 3 months, and 23 days with a few hours tacked onto it, and we had to shut it down, and we all kind of took screenshots of the thing saying, yeah, it was up that long. Right? So those are our pets. Our cattle are auto-scale groups within the cloud that allow to expand and contract as necessary for passing data. Software as a service. So this is being able to utilize what someone else has written to perform the operations we need. This is your CRM. This is your ERP. These started off really small. They were a little piece of what we needed to do, and they moved into being a core piece of our infrastructure. And we lose visibility with these, right? If we're implementing Salesforce as our CRM, do you think you get to see what Salesforce does within their data center and the interactions between their front-end interfaces and their back-end interfaces? Nope. That's what you pay them for. So making sure that your SaaS provider can provide you with a report of what their controls are and what their adherence to those controls are. So like a SOC 2 Type 2 report of how they adhere to their stuff. That ties into CASB, right? So cloud access, these are the original guys who were tying all of this security together for us. They're cloud-based tools, monitoring cloud-based tools. And I'm going to end on the cloud in a nutshell, because otherwise I can blow through the eroded edge. So the cloud in a nutshell is there is no cloud, it's just someone else's computer. And we're trusting that person as far as we are going to put controls around to run our things the way we say we run on, right? All right. The last piece that we didn't get to is eroded edge. And that's talking about how the fact that, has anybody heard that you no longer have a security perimeter? Anybody heard that? It's a great thing to make you think you don't need to buy a firewall anymore. The problem with it is you still have a perimeter. You just have a lot more perimeters. Every one of your users is now a security perimeter. Every one of your applications is now a security perimeter or more than one. So understanding what that eroded edge looks like and how you play with it over time is really important. And the last slide, since for some reason it won't let me jump through, is a lot of times I get asked when I get to the end of this, well, you didn't say anything about automation. Don't you need to automate some of this stuff? And the key here is all of this stuff should be automated. Your automation should play into every bit of what you do. Your network as you define it is defined as code. Your security controls are defined. Your access is defined. Your SIM is feeding into a SOAR system to automatically respond. So automation is through all of it. Any questions in the 30 seconds or so that I think we have left or that I went over? Come down and see me. I'm downstairs. Nexum has a booth with our friends F5 who help provide